friends, welcome to the Unit 1, Day 5 notes of our quadratic equations. This one is an application problem. The height of an object thrown upward from the roof of a building, 408 feet tall, with an initial velocity of 96 feet per second is given by the equation h equals negative 16t squared plus 96t plus 408, where h is the height of the object after t seconds. When will the height of the object be 450 feet high? Round your answer or answers to the nearest hundredth. So this is an application problem. We're going to use whatever method or means that we have. It's talking about when the height is 450 feet high, so it already actually gives us the value that we need to plug in for h. So in this case, I'm going to plug in 450 for h. So I have 450 equals negative 16t squared plus 96t plus 408. Next thing I want to do is get the zero, get zero on one side. So I'm going to subtract negative 450 on both sides. Sorry, subtract 450. I get 0 equals negative 16t squared plus 96t. Let's see, that's going to be minus 42. Each of these values are divisible by 2, it looks like. Yeah, 2, because of the 42. So I'm going to go ahead and factor out a 2 from each of these. So that gives me 2, negative 8t squared plus, what is that, 48t minus 21. And now I can go ahead and look at the options that I have. I think the best is going to be quadratic formula. I don't really want to factor that if it is factorable. I don't want to try a bunch of things if it's not factorable. So I'm just going to jump into the quadratic formula. A equals negative 8, B equals 48, and C equals negative 21. I like to do the discriminant part first just so I know what type of answers I'm going to have. And the discriminant, we remembered, is b squared minus 4ac. So in this case, I'm going to have 48 squared minus 4 times negative 8 times negative 21. So 48 squared, I do not have memorized, I'm sorry. 48 squared is 2,304. 2,304. And then negative 4 times negative 8 times negative 21 is negative 672. Subtracting these two, 2,304 minus 672 gives me 1,632. I don't know if that's a perfect square or not, so I quickly took the square root just to see what type of answers I'd have, and I got a irrational number, so I know that it's not a perfect square. Plugging this back into my quadratic formula, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So plugging this back in, so I'm going to have x equals opposite b, so negative 48, plus or minus the square root of 1,632, all divided by 2 times negative 8. So let's go through and simplify this as much as possible. X equals negative 48 plus or minus, so I'm going to go ahead and take the square root of 1,632, knowing that I don't need to keep it to the exact value because we're going to be rounding in the end, but I am going to give myself a little bit of grace here in writing down what values I'm going to use, because I just want to be as precise as possible, divided by negative 16. So with here, we're going to have two values. So let's see what we get. X equals negative 48 minus 40.39801975, all divided by negative 16. And so at this point I rounded. I need to switch. I apologize. I want to use approximately equal to symbols. So let's see, negative 48 minus 40.39801975 gives me negative 88-ish, then divided by negative 16. So I get the value, this value here. So that's about approximately 5.52 seconds so far. And then I also need to do negative 48 plus this. Divided by negative 16. So negative 48 plus 40.39801975 divided by negative 16. So that gives me about 0.48 seconds. So I have 2 seconds that is occurring here. So at about 5.52 seconds and 0.48 seconds, The object is 400 feet high. There's the application problem. That ends out the section Unit 1, Day 5 notes. Have a wonderful day.